absolute value function. Quiet. All right. You guys remember way back in Algebra 1, you did like y. In fact, we did it in here, didn't we? We talked a little bit about y equals ax squared plus bx plus c. That was called standard form, right? Now, back in Algebra 1, you were supposed to, hey, you were supposed to do some transformations of this quadratic equation. Now, the parent function, or you started with y equals x squared, didn't you? Y equals x squared. What kind of shape did I have there? Remember, a U shape. Now, parabolas. Yes, as some of you would say. Now, this is actually in standard form. Okay? This is in y equals ax squared plus bx plus c, where b and c are going to equal 0, right? This was called the parent function, and then you guys decided if it shifted left, shifted right, if it flipped upside down. Those are called transformations. Now, this is the start of doing, in Algebra 2, we're going to these transformations, we're going to look at all different types of functions. So you've got to get these transformations down. Okay? Either shift left, shift right, go up, go down, flip, make it narrow, make it wide. You have to learn that. You have to learn that for the rest of this course to be successful, because it goes on. We do logarithmic functions, and you have to know the stretch, and it gets very difficult, especially if you don't learn now. We're going to start out our transformations with the absolute value function. Does anybody know what that looks like? It's just a v. Okay, the absolute value function has the look of a v. Now, we like to graph absolute, in fact, many functions in the vertex form, not in standard form, okay? Vertex form is y equals a times the absolute value of x minus h plus k. Now, our a stands for slope. Our h and k make up the vertex. It's h comma k. Okay? Now, I'm going to show you a couple of different ways to graph any equation. To do that, what's the only way that you can apply one method of graphing every equation throughout your mathematical lives, including calculus and beyond? There's one way you can do it. It's not a form, it's a way to solve equations. That's a form. That's not a method. Make a t-shirt, right? And if you ever get stuck on your SATs or ACTs and they tell you to graph this line, just make a t-shirt. I got stuck many times in calculus, and the way I got out of it, I just made a t-shirt and got some points. Okay? So let's do that. Let's make a t-shirt. And we're going to graph what's called the parent function of the absolute value. This is the parent function of absolute value. Y equals the absolute value of x. Everything we do, and no matter what function we're looking at, we're going to compare our shifts or transformations to the parent function. Don't call it the mother graph. I think somebody was very angry when they did this. So it's the parent function. Okay. Are you ready? Are you ready? Now, remember, we choose x. That's the independent variable. What's the easiest number to compute with? Is a number easier than 1? 0. I'm going to choose 0 for x. Now I got to solve for y. Okay, so y equals the absolute value of 0. What does y equal? 0. Now I'm going to choose 1. Okay, I'm going to choose 1 for x. Absolute value of 1 is what? 1. So I solve for y, and that's 1. What do you think the absolute value of 2 is going to be? 4. Good. How about negative 1? Y equals the absolute value of negative 1. It's just 1. Because everything that comes out of absolute value bars has to be positive. So that's 1. What do you think negative 2 is going to be? Wonderful. So all we have to do is plot those points and graph it. Are you ready? Are you ready? Okay. So 0, 0, 1, 1, 2, 2. Negative 1, 1. Negative 2, 2. Now, you're probably wondering, well, why didn't we just get a straight line down this way instead of like turning the corner and going that way? Well, it's because our y values can never be negative, right? Unless something's going on with the function. So there's one way. That's a way that'll work with any mathematical equation for the rest of your lives. Want me to show you another way? Do you? Mr. T, can you show us another way? Why, I'd be happy to. Okay. So, we have our vertex form. Y equals ax minus h plus k, correct? What's my vertex? It's hk, right? What am I adding? So this looks like inside the absolute value bars, I'm subtracting h. What am I subtracting inside my absolute value bars and the absolute value of x? What number can I subtract without changing x? 0. Okay. What number am I adding outside the absolute value bars? 0. So there's my vertex, 0, 0. Okay. What's my slope? What is it in y equals the absolute value of x? What's this being multiplied not to change the value of this function? It has to be 1. So my slope is 1, and we normally write it as 1 over 1. With me? Then you're going to have to use the other method. Because all I'm doing is picking off, this is, if I were to put this in vertex, all I'm doing is putting this in vertex form. Y equals a times the absolute value of x minus 0 plus 0. Okay. That's the parent function. That's the parent function of that in vertex form. Okay. My a has to be 1. My h, this is my a, this is my h, this is my k. That's all I did here was pick off my H, K, and A. Yes, sir. No. All right, so if knowing this, I've got my vertex 0, 0 to the slope 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Draw your line. Now remember, this cannot be negative, so we're going to have to go back to positive y. Up 1 over 1, up 1 over 1, so on and so forth. I get my graph. So if you can put this function in vertex form and pick off your H, K, and A, it's a lot easier to use slope to graph it. Rather than your t-chart, what the hell is that? Okay, so that's the second way. What's the third way you can do this and the easiest way? Show me, Mr. D. I'm really interested. I want to do it the easy way. I might just show you. Thinking about it is two people asking. What is the easiest way to do anything in math? Calculator. It even says you can find using our graphing calculators. You can find the absolute value command under the math menu, then go to numbers, and then hit number 1. So, what key do we use to graph? That's right, the y equals button. Okay, so go to your y equals. We're going to graph our absolute value function. Again, the way we get that is we're going to hit the math button. So I'm going to hit the math button. Then I'm going to scroll over to num for numbers and highlight number 1, which happens to be highlighted. Hit enter, and I get ABS, absolute value. Then I'm going to put in my X, close the parenthesis, and hit graph. And there's my function. Isn't that nice? That's probably the easiest. Yes, Darren. Oh, there's an X button here. Okay. What's really nice about this, because you're going to be asked to make little charts here. Again, pay attention here. I'm going to save you some time on a quiz or test. There are some problems where they're going to ask for the chart. Well, guess what your calculator can do? Give you the chart. Hit your second button. And hit the graph button. And lo and behold, there's my chart. Hit the second button. And hit the graph button. And it brings up your chart. Now, on the chart, you can easily see where our vertex is, can you not? You can easily see where our vertex is on the chart. Now, sometimes it won't show it because it's not a whole number, but most of the times you can get your vertex off of your calculator. Obviously, it's going to be 0, 0 because my y numbers start repeating after 0, 0. Do you see that? I got 1, 1, 2, 2, 3, 3. It's making that V. Comprendes? So I just showed you a real big shortcut on graphing these functions that you can do when we get into tougher functions. Can we go on now? Everybody copacetic? Everybody okay? I'm going to graph a function. So I'm going to go to y equals. Hit the y equals button. Okay. Then it says here, I'm going to hit my math button. And then I have to highlight num. And then enter because it's already highlighted ABS. And then put in my x, parenthesis, graph. It's the absolute value of x. Now, something. Use that one. All right, let's do some transformations. Let's do some transformations. Okay, number one. I'm subtracting 2 inside the absolute values. So I'm inside the absolute values. I'm inside the absolute value bars. Okay? Looking at your formula. If I'm inside the absolute value bars, what letter am I looking at? H, right? Can't change that. So we're looking at our H here. Now, when I'm looking inside the absolute value bars, it's actually going to shift our graph. The opposite direction of the sign. Well, first of all, it's going to shift it left or right. In the opposite direction of the sign. Okay? So in other words, if my sign is positive, which way is it going to shift? To the left. If my sign is minus, which way is it going to shift? To the right. So, looking at there's only one transformation here. I'm minusing an h. My h is 2. Which way is this thing going to shift? To the right. My vertex is going to shift to the right 2. Everything else stays the same with the graph because we're not changing the slope, we're not changing k. So I'm going to do my 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Here's my transformed graph. Okay? Because it shifted to the right 2. All right, let me tell you why you have to go opposite the sign. Let me do number 2 first. Again, I'll tell you why in a minute. Number 2. Which way am I going to shift this? It's going to shift to the left. How many? 3. So my vertex would normally be at 0, 0. It's going to shift to the left 3. 1, 2, 3. Everything else stays the same. So there's my graph of the transformation, the absolute value, x plus 3. All right, now, Jonathan said that And he didn't like all this wording in there. It's hard to read. Let's look at it another way. In my formula, because you don't listen. In my formula, my h is a minus h, right? Here I have a plus 3. How do I make that plus a minus? Using that 3. My formula says, well, my h has to be a minus sign in there. How do I make this plus 3 into a minus 3? It has to be a negative 3, right? That's the only way I can get a plus 3. It has to be a negative 3. Now, does that make sense that I shift it left? It all depends on the sign. In fact, we're going to have problems where you're going to have to look at just the formula. You're not going to have a graph. And it says, well, looking at the absolute value of x plus 3, I know that has to be a minus, so that 3 has to be negative. That's left. That's why it's the opposite sign. When you're in the absolute value symbols, anything, the h is always going to be opposite the sign. Look at the negative 2. I have a minus sign there. So the 2 stays positive, right? I don't have to change that sign because it's already a minus. So I leave that 2 a positive. That's a positive 2. Then, hence, I shift it to the right 2. Does that make sense? It's actually the same sign, but it's opposite of what's there. Number 4 is completely different because we're not dealing with h anymore. We're dealing with k. Okay? K. Well, let's look at that. Okay, k is outside the absolute value bars, right? In my formula, k is positive. So I don't have to worry about switching the sign. I can just follow the sign, right? It shifts this up or down the same as the sign because I don't have to change it to minus. So it shifts up and down and follows the sign. So if my k is a positive number, like plus 3, or in this case, plus 2, it's going to go up 2. If it's a minus sign, like minus 4, it's going to go down 4. Everything else stays the same. Okay, so I'm going to shift up 2. Everything else stays the same. Slope 1, 1, 1, 1, 1, 1. Slope 1, 1, 1, 1, 1, 1. All it did was move my parent graph up 2. And this one's going to move my parent graph down 4. So our k follows the sign. Everybody understand what my k does to my parent function, my parent graph? All right. Number 8. What's different in number 8? Yeah, my slope or my A is -1 instead of +1. Yeah, it's going to flip my entire graph. When my A is negative, okay, when my A is negative, less than 0, I'll put negative, flip the graph. Okay, so I'm just going to flip it. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And there's my parent graph flipped. Are you with me? Okay, next one. I think I can finish this up today. Okay, what's going on with number 6? Yeah, my slope is now 3. If I write that in as a fraction, it's going to be 3 over 1. So I'm going to start at my vertex 0, 0. Instead of going up 1 over 1, I'm going to go up 3 over 1. Up 3 over 1. Up 3 over 1. Now, instead of doing that all over again, our absolute value functions have what's called an axis of symmetry, and it goes through h. Okay, my h happens to be 0 here, right? So I have x equals 0. That's my vertex. That's my h value. Means it's symmetric, which means everything on this side has to be exactly the same over here. So if I look at this one, this point, it has to be 1 away from the axis of symmetry, so 1 away this way. This one's 2 away from the axis of symmetry, so I just go 2 over here. This point is 3 away from the axis of symmetry, so I'm just going to go 3 over here. What? Now, a couple more things. I know this is a lengthy lecture, but it just, you have to know it. What happened to my graph? What happened to my graph when A was bigger than 1? Looking at these two graphs here, what happened to my graph? Narrower, right? So when my slope is greater than 1, my graph got narrower. We have a mathematical term for that. It's called stretch. Now, there's another situation we have to worry about. What if A was a fraction between 0 and 1? A was greater than 0 but less than 1. That means it was a fraction between 0 and 1. It would be wider. And guess what? We have a mathematical term for wider. It's called, compressed. Okay? Now, you don't have to use the mathematical terms, but it would be nice if you're going to go on in mathematics to learn those. If you put down wider, narrower, that's good for this class. All right, one more thing. I got to talk about domain and range. For the domain, for this course, domain for all absolute value functions. Look at any of these absolute value functions here. What's my domain? Where does it start on my x-axis for all of them? Negative infinity, right? Where's it going to end up? Positive infinity. So for this course, your domain for absolute value function is going to always be negative infinity, positive infinity. Negative infinity, positive infinity. Negative infinity, positive infinity. Now, let's take a look at the range. This is the last thing. Look at your graphs. Now, the range can be different. Okay, look at these two. Okay, my range here starts at 2, goes to positive infinity. My range here is -4, goes to positive infinity. My range here is 0, goes to negative infinity. What's common with that 2, -4, and 0? They're what? Yeah, it's always going to go to infinity. We don't know which one. It could be either positive or negative infinity. But I'm looking at the lowest number for my range. Okay, this one is 2. This is going to be 2, positive infinity, including 2. Okay, the range for this one is going to be -4, positive infinity. The range for this one is going to be 0 to negative infinity, including 0. What's the vertex for this one? 0, 2, right? That's the vertex. What's the vertex for this one? 0, -4. Okay, what's the vertex for this one? 0, 0. Do you notice where my range starts on these? It's my K. Okay, it's K. So your range for absolute values in this course is going to be bracket K of the vertex, comma, either positive or negative infinity. So for this one, look at the equation. What's my K here? What's my K for y equals 2 absolute value of 0, right? 0, you're adding 0. That's my K. Vertex is going to be 0, 0, because that's what you're subtracting inside. So my A is positive, so it's going to be my K is 0, my 2 is positive, so it's going to be positive infinity. What's my K here? 0. What's my A value? Negative or positive? Positive, so it's going to be positive infinity. I don't even have to draw the graph for these. What's my vertex here? Careful. What's my H? Opposite sign. Here's my vertex. Are we good? Do you think you can do the rest of this page? I know I did a lot of talking and it's a lot of info here.